Now I'm going to skip a couple of lines and put number 1 because I want you to see what's going to happen. We're going to start. These are going to be, and if you haven't seen the other videos, you may not know what I'm talking about, but I'm going to say that these are a monomial over a binomial. Now that just means that the top is not going to have adding and subtracting like 8, and the bottom is going, it may have a square root in it, the bottom is going to have adding or subtracting in it. Binomial, two things. We're going to do 6 plus the square root of 5. Now we're going to do a different way of reducing 2. You cannot cancel. I'll just put can't cancel because not multiplication, exclamation point. We're not making these multiplication, and you cannot start canceling the 8 and the 6. That's not going to work. You can only cancel if you had all of this in the top. It's not going to happen. So just in this case, don't be canceling until we get to the last step, and I'll show you how we're going to handle that. Now in lesson 24, we said that if you had something like 8 over the square root of 5, this is just notes, this is just whiteboard, so you don't have to write this down, that you could rationalize it. That may be the problem we worked. And that will actually get rid of the radical in the denominator. But look what happens here. We are going to rationalize, but we're going to rationalize a little bit different. Because if you multiply by square root of 5 over square root of 5, the top is 8 square root of 5. That's not a problem. But look what happens on the bottom. You have to distribute, and you get 6 square root of 5 plus the square root of 25, which is 5. But you still got a radical on the bottom. You can't cancel it. That's not multiplication. So you get into a bind when you try to rationalize when the bottom has adding and subtracting in it. So what we're going to do is we're going to take a form of 1 that's called probably, well, we're going to write it here and then we'll just finish the problem at the bottom. We're going to use, the form of 1 we're going to use is called the conjugate, I don't know where that name came from, of a binomial. And I mean, we use them for other things too. The conjugate of a binomial, like a plus b. Let's say you have a binomial that's a plus b, then its conjugate is a minus b. The conjugate of the binomial a minus b is a plus b. Now, I know you wonder why that works, but you'll see in just a minute. It goes back to foiling from Algebra 1. So the way to get rid of the denominator is take the conjugate of it. Well, a and b stay the same, except the sign between them becomes 6 minus square root of 5. And if you're going to do it in the form of 1, you have to do it top and bottom. Now, I'm going to put equals. On the top, you are going to distribute, and on the bottom, you're going to distribute or FOIL. So we're going to come down here and do that. You're distributing the 8 to both of these, and you're going to do that every time. This goes back to lesson 20, when we multiplied, I think it's 23, right here. We distributed, like when you had parentheses and you've got to distribute to both of them, and then we have one where we FOIL, and we're going to be using both of those from page 55. So on top, 8, and I'll take it slow, because once we get it, you've got the concept. It's just cleaning, doing all the arithmetic. So 8 times 6 is 48, and then 8 times negative 5 is negative 8 square root of 5. Now notice, the 8 was rational on the outside, and the 5 was inside. So that's why these were both outside. Now put your big fraction bar, and then now we've got to FOIL both of these. Now it might be a good idea, and I didn't do this yesterday, but I think I'm going to rewrite it down here to see what we're FOILing, because it's a little messy when you're trying to look up here and look down here too. So let's just rewrite that. And 6 times 6 is going to be your F, which is 36. And then 6 times the negative 5. Now look, outside, inside, that's going to be negative 6 square root of 5. So that's FO, or as I say, distribute to both of those. Now distribute the square root of 5 to both of those. That's going to be your I and your L. These two, that's an inside, that's an outside, is going to be plus 6 square root of 5. And then the last is going to be these two, which is going to be minus the square root of 25. This is why we pick the conjugate, because if you multiply any binomial, doesn't even have to have square root in it, times its conjugate. See, it doesn't even have to have variables or anything in it. It doesn't have to have radicals. You're going to always get rid of the O and I. They're going to add out. Now, why does that help? Because now we have 48. That should get rid of our square root on the bottom, which was our goal in lesson 24 and 25. You can't leave a square root in the denominator. So these are gone, and I have 36 minus 5, because the square root of 25 is 5. 48 minus 8 square root of 5 over 31. Now, at this point, I've always left them like this, but people get confused on whether you can cancel. Now, this one, I don't think you would be tempted to try to do it, but you can't cancel unless you have multiplication. What we're going to do is we're going to start, and this is going to make a lot of things we do later a little bit easier, some stuff we do with our calculator. If you recognize that, and this is what I did yesterday, if you recognize that if you're adding fractions, this was my whiteboard yesterday, 2x plus 2 6 plus 1 6 gives you 2 plus 1 over 6, then you also want to recognize, and we very rarely do it, but you can actually take a fraction, especially like we're doing here, and you can distribute the denominator to both of the top. So you can go backwards. So if I have 8 plus 3 over 11, I can actually distribute that 10 to both of them. So I can take, in this case, we're going to do that, and we're going to put 48 over 31 minus 8 square root of 5 over 31. But it's so much easier to separate them, and you'll see some in just a minute that will reduce. But we're going to start separating them like this, and then you're not tempted to cancel until you get to that last step. Now that's number 1, and I did put a 1 up there. Let's do number 2. They're all set up exactly the same. The arithmetic just looks a little different. Let's do 2 square root of 3. That's your monomial over 4 minus the square root of 2. When you have a binomial on the bottom, your rationalizing has to be the conjugate of that. So that's going to be 4 plus the square root of 2 over 4 plus the square root of 2. Now remember, you're going to distribute on top, and you're going to FOIL on the bottom. That you got to remember. That's lesson 23. So the 2 square root of 3 is going to go to the 4. You see the 2 and 4 are outside, so that's going to be 8 square root of 3. We did that in geometry. Plus 2 on the outside. There's a 1 right there, so I've got 2 square root of 6. And then on the bottom, we're going to take the 4. We're going to do FO. So that'll be the first 2 here. So that'll be 16 plus 4 square root of 2. Now we're going to do our I, which is these two, outside, inside, rational, irrational, negative 4 square root of 2, minus 4 square root of 2, if you want to say it that way. And then the negative times the positive is going to be negative square root of 4. Now, that's the only way you can get rid of the radical on the bottom, because look, those radicals are gone. Now, even though this is a radical, it's rational because we know it. We know that one. It'll always be one that you know, like square root of 25 or square root of 36 or 49. It's going to be a number you know. So your top is 8 square root of 3 plus 2 square root of 6. Now, you might separate it here. Because I'm doing notes, I'm going to go ahead and do all the work. It's going to be 16 minus 2. There's my square root of 4, which is 8 square root of 3 over, and I don't know that you would recognize it from this one up here to this one down here. If you leave that as an answer, I'm going to say not simplified. That one was simplified, either this one or this one. This one isn't. Let me show you the easy way to simplify it by separating it. So we're going to put 8 square root of 3 over the 14. Just distribute the 14. That's all you're doing. Well, I did it again. I keep wanting to make that as a 14. 8 square root of 3 over 14 plus 2 square root of 6 over 14. Now look how much easier it is to reduce it. And it will be the outside numbers because you won't have a square root on the bottom. So these will reduce. 2 will go 4 times. 2 will go 7 times. Now this is a case where both of them reduce. Sometimes both of them do. Sometimes neither one do, like that. And in this case, actually both of them do. And we end up with 4 square root of 3 over 7 plus 1 square root of 6, or just square root of 6 over 7.